Hi guys, Vadim here again. Last time we did navigation using angles and things in Carla. Now I had this poll where I asked you where do we need to go next, and I've got huge amount of votes, 7, right? So I'm a YouTube magnet, as you know. So, and the decision is we need to go after this option, which is blending GPS and visual or computer vision for navigation. I've made a remarkable drawing of what we're talking about here. And today I'm just gonna walk you through the concepts, how this could be done. And in later videos, we'll start implementing some of this. So the situation that we've got is here. The car needs, let's say the car needs to get to this point. So the red arrow is our GPS direction or where we need to go. And we'll talk about more details and specifics how we do this. Because obviously the car needs to go a lot further to a particular destination. But for now, let's just say the car needs to get here. However, the road goes there. So the green arrow is how we should go. And the limitation here is we just need to use the road and we need to stay within our lane, essentially. That's the restriction. And how we could do these things, I've got a couple of options for it. And I've prepared this massive slide. It's just one slide. So option 1, you train a neural network model. And I'm gonna walk you through step by step what's involved. In a nutshell, we need to generate training images, right? And with the images, or the input to the model will be the image or what the computer or the camera sees and the GPS vector. And what I'm talking about here, so imagine we've got a footage or shot from this camera looking this way. And the GPS vector that we've got would be pointing that way. So that's our X inputs into the model, okay? And I'm gonna let you take your time to sort of digest it. But so if effectively we put the image and the GPS vector that the car needs to go. And the output, or the Y, what we're trying to predict, is the steering angle. And if we go back to the image, in this case, the steering angle, for where the car is right now, the steering angle is 0 because the car needs to continue going here. And so as far as this image is concerned, it will be at this point. And then there will be another image later that will show that the car needs to start turning. Okay. The camera itself, we're going after semantic segmentation, which is not all colors and everything, but colors will be dedicated to particular things, like the road will be this red, maroon color, the lane markings will be yellow, the edges of the road will be yellow, that kind of stuff that you have seen in my previous videos. The GPS vector, again, needs to be relatively close to where the car is, because it cannot be the final destination, because imagine if according to the route car needs to go here, but the destination is somewhere there, like on the left, right? Because the car needs to go right and then eventually turn left and get somewhere much lefter from here. Lefter, yeah. New words, Vadim, well done. Now, the GPS vector goes hand in hand as an input for each image. And then to get the correct steering angle, we're gonna be using the cheats from the simulator. We need to work out, we need to give this correct label. So in this case, the label will be 0 because the car will need to continue going straight. And the way we can work this out is we know where we are within the lane, and we know we can check quickly whether we can start turning like right now. And then we'll quickly see that we'll have this edge of the road, which we'll get from the simulator, just accessing our current waypoint and lane markings around it. So you will get to that when we implement this. But this is just the beauty of the simulator, where to label these images, you can use these simulator cheats. That was my initial idea why we need to use simulators for this. And that's where they really shine and bring exceptional value into this whole autonomous driving thing. And then after that, we'll just train the model similarly to what I've trained in the past. And obviously we'll be limited by, how much we put resolution in the imagery, and then how big is your graphics card is, and that's when becomes this processing capacity may become an issue. So that's option 1, neural net, and hopefully you got the idea. Option 2, we go in the reinforcement learning path. And previously I've nearly done an environment using stable baselines 3. However, I still didn't get it to work, and maybe this time I'll be able to just polish all the imperfections and it will work. But creating environment according to the restrictions of stable, or following the guidelines of the stable baselines, creating agents, adding collision events, and making sure it works for Carla, it would be the hardest part here. And then normal sort of reinforcement learning type approach, we need to define how long one episode could be, because we don't want to really blow up performance restrictions, and with computing power that we've got, we can't just say, okay, 5 minutes per episode, or we'll go try to complete this navigation route. It's a bit too much. So we will have to make it somewhat limited to maybe 20 seconds maximum, and see if the car is starting to get closer to the destination, that kind of approach. And in reinforcement learning, we just need to also design the reward approach. So here we have minimum collision, because a lot of points is deducted for having collisions. This is how the model learns, by trying things and colliding with something and learning that that's not a good idea, that kind of thing. And it gets closer to destination, which is when it starts getting positive points and also faster time. And then this is how the model basically trains. So that's the essence of how this could be done. In the next video, we're going to go into more details and more implementing. I'll probably go option 1 first, because I think it's more achievable. It's only limited by the graphics card. At meantime, guys, I hope you're enjoying this, and I completely understand that I can't just ask you to make your friends subscribing to this channel, because this is a very niche topic. I've got a very limited number of you liking this stuff, but I want to help you develop your skills and finally crack the whole autonomous driving, and hopefully it will happen sooner. And guess what? I had a bike accident on the weekend when I got hit by a car. Nothing, just a couple of scratches. I was very lucky. However, that's another point where we need to get autonomous driving pretty quick, so we will get safer on the roads, because when a car drives, it will not forget to check the mirrors and look for cyclists. Like, it will just do it all the time. So that's my rant for the week, and hopefully you enjoyed this video. I'll see you shortly with the implementation of this. Thank you, and see you later.